Welcome to my channel. Your tutor Mariam is here. It's the 7th video of Introductory Physics 1 and the 3rd video that I'm going to talk about the motion, which is the second subject in Introductory Physics 1. In this video, I'm going to solve a couple of simple problems about velocity, and these are the simple problems, but it always show up in the exam. So if you are new to Introductory Physics 1 and like to learn more about the velocity, watch this video till end. Also subscribe for more, and if you like my videos, please hit the likes button too. It encourages me to make more video. You ready? Let's get started. Let me start with a simple example. I have a ball and I'm gonna throw a ball upward, and of course because of the gravity, ball gonna come back to the same position, right? So what do you think about the average velocity of the ball? As you saw in the previous video, the average velocity gonna be delta V is equal to delta x over delta t, right? So delta x gonna be the displacement and delta t gonna be the time, right? So if my ball come back to the same position it was, then delta x gonna be 0, right? And no matter what time I have, my delta v gonna be 0, right? So the average velocity for the ball gonna be 0, okay? Let's look at another example. So I have an airplane, and my airplane flies with a constant velocity. What do you think about this? What is the average velocity for the airplane in this case? Feel free to pause the video and think about it. So here I mentioned the average velocity, right? And also I mentioned my airplane fly with a constant velocity, right? That means my delta V is gonna be constant, right? Constant, correct? Sounds like a simple problem, but let's see how it's gonna show up in your exam. So here is a question 1. For which of the following one-dimensional motion average velocity has the same value as instantaneous velocity? A ball thrown directly upward rises to the highest point and falls back into the ground. A spacecraft orbits the Mars at a constant velocity. Feel free to pause the video and think about it. So here, in the case of the ball, like A, we know delta V is equal to 0 because we just saw it in the previous slide, right? So the average velocity in this case is going to be 0, okay? But what about the instantaneous velocity? Instantaneous velocity in this case, that I'm going to show you as Vs, cannot be 0. Why? Because we have a gravity, right? Which we can show it as a g, and it's equal to 9.8 meter per second square, right? So if I have a gravity, that means I have an acceleration. So my instantaneous velocity cannot be 0, okay? How about B? So it says the spacecraft has a constant velocity, right? So that means my delta V gonna be constant, right? So in this case, my instantaneous velocity also gonna be constant, correct? Because in this case, I don't have the acceleration, and that means my instantaneous velocity and the average velocity gonna be the same. So the answer gonna be B. Let's look at another example. Okay, in this question we are dealing with the velocity equation. It says the following equation gives the position x of a particle, and A asks you which situation is the velocity of the particle constant, right? So we know that V is equal to delta x over delta t, right? And delta x, that means x2 minus x1, t2 minus t1, right? And then if I do the simple calculation, I can write down this equation, which is the displacement based on the velocity and time, right? This is a standard equation we all know, right? So for A, it's a time to choose which one is the correct answer based on this equation. Let's look at the A. So A looks like my V is equal to 5 and my x naught gonna be 1, right? So sounds like this is the right one, correct? Okay. How about B? So if I look at this equation and compare it with the standard one, it's like this t right here have a square. However, in the standard one, I don't have the square t, right? It just has a linear relation with the displacement, okay? So that's not a right answer for that. How about C? So if I look at equation C and I rewrite it, is like x equal to minus 6t plus 9, right? So it looks like the same equation, and here my v gonna be minus 6 and x gonna be 9, right? So this one also the right answer. How about D? So this is kind of the tricky. If you are in the exam, you might think, okay, this is the right one, and then it's just a fraction, and you go with this. However, look at this part right here. This is based on x, not t. So this is also not a right answer. How about part B? So we are looking for a negative direction of x and v, correct? So technically speaking, it means which one has a negative velocity. And we already know that, which is gonna be equation C, correct? So this one gonna be for B, correct? Because my V here is minus 6, so it's negative, and that's all is asking in part B. So in this problem, we are dealing with the motion of the car that is given by this equation right here, right? And you say x is in meter and t is in second. So what I want you to notice is if your problem mentioned the dimension. So it said if meters, second, millisecond, meters, or something like that, okay? So always be careful about the dimension, especially if your problem emphasizes that. And then it asks you to calculate the displacement of this car at 2 seconds and 3 seconds. So let's say how we can solve this problem. So I have this equation right here, 2t plus 5, right? Let's solve it for t equal to 2 seconds. So here I have x equal to 2 times 2 plus 5, right? which is gonna be 9. How about t equal to 3 seconds? So here I have x equal to, let's write it as x1 and x2, t1 and t2. So it's gonna be 2 times 3 plus 5, right? Which is gonna be 11. How about the average velocity? So you know delta v is equal to delta x divided by delta t, right? Which is equal to x2 minus x1, t2 minus t1, correct? So let's see what I got here. My x2 gonna be 11 minus 9, right? And then my t2 gonna be 3 minus 2, which is equal to 1, and this one gonna be 2. So my answer gonna be 2 meter per second, correct? Okay, let's look at the last question. I drive a car for 4 kilometers at 60 kilometers per hour, and then I got run out of the gas and stopped. Then I have to walk for 3 kilometers for 30 minutes, and then is asked for the displacement from the beginning of my drive, right? So let's look at the displacement. I drove for 4 kilometers, right? And then I had to walk for 3 kilometers. So it's gonna be 7 kilometers, okay? So my answer can be A, B, or C. So let's look at the part B. It asks for the time interval in minutes, okay? So I know the v gonna be x over t. Let's say delta x delta t, right? So here I have my v as 60 kilometer per hour equal to 3 kilometer, and I don't know the time, right? So if I do the simple calculation, I can tell my t is equal to 50. So what I want you to be careful here is t is in hour, okay? So I can't add 15 hours with 30 minutes I have here because they don't have the same dimension, okay? So I have two choices. I can convert hour to minutes, or I can convert minute to hours, and then at the end I convert all to minutes. It's up to you what you're gonna do, because here is ask the time in minutes, okay? So if I don't be careful about this here and add them up together, like say 30 plus 15 is gonna be 45, right? And I'm gonna say, okay, the answer gonna be B, which is totally wrong because they don't have the same dimension, and I have to convert this. So what I'm gonna do, I'm gonna convert hour to minutes. So how I'm gonna do that? I know 1 hour is equal to 60 minutes, right? And I'm gonna use this conversion factor. So now, based on this conversion factor, I can say my 15 hours is gonna be times 1 hour minutes. So rule number 1, this one must be cancelled with this one. That's why I said it's gonna be 1 hour and it's gonna be 16 minutes. So 15 times 16 gonna be 900 minutes. Okay. If you have a problem with this part and you don't know what I did here, I highly recommend you to watch my first playlist that I call it as a measurement. In that playlist, I explain all conversion factor and I solve a couple of problems for you. So moving on, here I'm gonna add them together, like I have 900 minutes and then 30 minutes here, so it's gonna be 930 minutes, correct? So my answer gonna be A. I hope this video helped you to understand the subjects better. If you enjoy my video, please hit the like button and I'll see you in the next video.